From now onwards, our discussion will be regarding ideal gas or perfect gas. Ideal gas or perfect gas can be defined as it is the gas which obeys the ideal gas law is known as ideal gas. And later we will see what is that ideal gas law. Real gas is the gas which does not obey the ideal gas law is known as real gas. Okay, this is a very simple definition for ideal gas and real gas. Ideal gas is the gas which obeys the ideal gas law and hence it is called as ideal gas. Real gas, it doesn't obey the ideal gas law and hence it is called as real gas. We have some fundamental laws of gases. So let us discuss one by one, which is Boyle's law. Boyle's law states that if unit mass of gas is maintained at constant temperature, I repeat, if unit mass of gas is maintained at constant temperature, okay, constant temperature, then the volume of the gas is inversely proportional to the pressure of the gas. Volume of the gas is inversely proportional to the pressure of the gas when the temperature of that gas is kept constant. And this expression can be written as, if you remove this proportionality constant, it you will get the PV equal to constant. So Boyle's law says PV equal to constant for a particular given gas when the temperature is constant. This PV is equal to constant can be written as P1 V1 into P2 V2. Okay. For if you write this expression for different states, then P1 V1 equal to P2 V2. Then if you rewrite this equation again, P1 by P2 equal to V1 by V2. Okay, this is an expression of Boyle's law, which states that for a given mass of a gas, unit mass of a gas, if you keep the temperature as constant, then its volume is inversely proportional to this pressure or absolute pressure of gas. Now, Charles law. It states that if unit mass of gas is maintained at a constant pressure, okay, if the unit mass of gas is maintained at a constant pressure, then volume of the gas is directly proportional to the absolute temperature of the gas. Okay. So what Charles law says is, if you keep the pressure of a gas or pressure of a unit mass of gas is maintained at a constant pressure, then volume of the gas is directly proportional to its temperature. Then if you remove this proportionality sign, you will get a constant, which is V by T equal to constant. So if you rewrite this equation, V1 by T1 equal to V2 by P2. Sorry, T2. This is what the Charles law. Now Gay-Lussac law. This Gay-Lussac law states that the absolute pressure of unit mass of gas varies. The absolute pressure of unit mass of gas varies directly with its absolute temperature. Okay, which means that pressure of a given gas is directly proportional to its temperature when its volume is constant. Okay, when its volume is constant, the pressure of a gas is directly proportional to its absolute temperature. So this equation can be written as P by T equal to constant. If you remove this proportionality constant, you will get the, if you remove the proportionality sign, you will get the constant. P by T equal to constant for a given gas. So that is what the Gay-Lussac law. If you rewrite or if you express in other way, P1 T1 by equal to P2 T2. This is what the Gay-Lussac law. Now Avogadro's law, very familiar law which we have already studied. It states that the equal volume of different ideal gases. I repeat, it says that the equal volume of different ideal gases at the same pressure and temperature contains the same number of molecules. The Avogadro's law states that the equal volume of different ideal gases at the same pressure and temperature contains the same number of molecules. Number of molecules equal to N equal to total mass of a gas divided by molecular weight. M by M equal to N, or M, or total mass of a given gas, is equal to number of moles into its molecular weight. So that is what the Avogadro's law says. Now we will discuss about ideal gas law. Ideal gas law is a hypothetical gas, or ideal gas is a hypothetical gas which obeys the law PV equal to RT. PV bar equal to RT at all pressure and temperature is called an ideal gas law. Okay, this is what the ideal gas law. The law or the gas which obeys this law PV equal to RT at all pressure and temperature is called ideal gas. Okay, so let us consider this ideal gas equation. PV or V bar equal to R bar into T. So call this as equation 1. From Avogadro's law, when pressure is 760 mm of Hg, so which is equal to 1.013 to 10 to the power 5 Newton per meter square. At this pressure, at temperature 273, and specific volume is 22.4 meter cube per kg mole. Okay. So R bar equal to PV by T, where R bar equal to, substitute at this pressure and this volume and at its temperature, R value is 8.3143 kilojoule per kg mole Kelvin. This is what the ideal gas constant R is. Since V bar is equal to V by N, where capital V is the total volume and N is the number of molecules of the gas. The equation of states for an ideal gas can be written as, so instead of V bar, if you substitute by V by N, where V is the total volume and N is the number of moles of the gas. Okay. So that is what the specific volume of an ideal gas can be written as. So wherever V bar is there, just you substitute as PV equal to N into R bar into T. Call it as equation 2. Also we know that N equal to N by mu, where mu is the molecular weight, N is the number of moles, M is the mass of a given gas divided by molecular weight. It gives the number of molecules. Then PV equal to, so instead of N, you can substitute as M by mu in equation 2. You will get PV equal to M by mu R bar into T. Call it as equation number 3. Where R is here, characteristic gas constant, R equal to R by mu. Wherever R by mu is there, R bar mu is there, you can replace it by R. Replace it. Okay. Here, there are 6.23 into 10 to the power 23 molecules per kg mole. If n kg moles of gas, the total number of molecules n are n into A. Okay. Where small n equal to n by A. Then PV equal to, then the expression becomes small n, wherever small n is there, replace it by n by A, capital N by A. Okay, PV equal to N into R bar A. So equation, call it as equation number T. PV equal to N K into T, where K is Boltzmann constant or K equal to R bar by A. A is Avogadro number. Okay, which is R bar is 8314.3 divided by 6.0 to the 10 to the power 26, which is equal to 1.38 into 10 to the power minus 3 joule per mole Kelvin. Therefore, the equation of state of an ideal gas can also be called as the equation of state of an ideal gas is given by PV equal to MRT, R is R bar by mu, which is characteristic gas constant R, PV equal to N bar T, PV equal to NKT. These are the three expressions are nothing but the ideal gas expressions, or this equation can also be called as equation of state. Now let us prove that Cp minus Cv equal to R, which means that specific heat at constant pressure is minus specific heat at constant volume, which is equal to characteristic gas constant R. Okay. We know that the enthalpy of any substance is given by H is equal to U plus PV. This definition already we defined in first unit itself. Okay. The enthalpy of any substance is nothing but it is sum of internal energy plus product of pressure and volume. H equal to U plus PV is an enthalpy of any substance which is given by this formula. H equal to U plus PV. Call it as equation 1. Now for any gas, H equal to U plus RT. For any ideal gas it is. Okay. For any gas it is H equal to U plus RT. Wherever P is there, we can replace it by RT. Call it as equation 2. Hence, we can write as H is function of temperature. Okay, H depends on the temperature. We can call like that. So call this as equation number 3. Now, only for an ideal gas, so dH equal to du plus R into dt. If you just write this equation 2 in terms of differential form, or this differential form, you can write it as delta H equal to delta U plus R into delta T. Okay. Now, delta H equal to CV delta T plus R delta T. If this differential form can be written it as simple mathematics here. Okay, simple form. We will get delta H equal to CV into delta T plus R into delta T. Now, delta H equal to Cv plus R, take delta T as common and call it as equation number 4. Since H is a function of T only, since H is the function of T only, and by definition, from the definition of specific heated constant pressure, we can write it as Cp equal to dH, differentiation of enthalpy value with respect to time at constant pressure, or dH equal to Cp into dt, call it as equation 5, and delta H equal to Cp into delta T, call it as equation 6. From equation 5 and 6, we can write it as Cp equal to Cv plus R. Okay, from equation 5 and 6, we can write Cp equal to Cv plus R, and Cp minus Cv equal to R here. 7, call it as equation 7. The ratio Cp by Cv is of importance in ideal gas, can be called as gamma. Cp by Cv is gamma. It is adiabatic constant. Then Cp equal to gamma into Cv, we can rewrite from equation 7. If you substitute value of Cp here in equation 7, you will get gamma minus 1 into Cv equal to R. Okay. Here Cv equal to R by gamma minus 1 divided by Cp equal to gamma into R by gamma minus 1. This expression is useful to calculate, or this expression is useful to solve any kind of problems regarding ideal gas or perfect gas.